Is it good to go?
I guess we're starting now.
Are we?
Sounds like it. The music stopped.
All right. Welcome to the session which we have. This is called Build Mission Critical .NET Microservices. So I'm Chaco Daniel. I'm pretty excited to be here. I'm one of those key members who joined Service Fabric a very long time ago. So I'm glad to be here to share my experiences and also talk about what else which we have in plan for Service Fabric. And this is...
Hey guys, I'm Deep. Some of you know me, some of you don't. I just want to do a quick check. At the back of the room, can you hear us fine? Everything good? Fantastic. We're really excited. We hope you are too. So let's get started.
Okay, let's do it. So here's the agenda which we have. Actually, although it looks like there are only 5 things, it's going to be fully packed. So we would start touch on Service Fabric updates as to where we are taking this particular platform to, what features are coming, what are all in the pipeline, and also, fortunately for us, there are two key customer representatives out here who actually have taken and wanted to showcase their microservices implementations. Eric Boyd from ResponsiveX, and also Kai Walter from Zeiss, who's going to talk about it. And then towards the end, we'll cover where are we taking our serverless platform to Service Fabric Mesh. We'll talk about the roadmap and how we're going to bring the goodness of Service Fabric to more than Service Fabric. That actually is what we'll talk about. So the expectation here is, the expectation here is that you guys already are familiar with microservices and also about Service Fabric before. So, but I'll just start off at a very high level, just talk about where am I seeing in terms of industry, where is application development going. We actually see that today as a part of migration to cloud, and also basically I call it lift and shift, or born in the cloud applications. Most of them are doing microservices. What does it mean? It just means that they actually are autonomous decoupled services, and they can be using any platform or any programming model as such, and so it doesn't really matter as long as the API surfaces are very clean. And a lot of customers have started to use like external stores, and some of them absolutely use in-memory databases too. And the key there is there are a lot of they're interconnected by intelligent messaging, routing, and eventing. And a lot of you guys already might be familiar with Envoy. It's becoming one of those standardizations for how do you do this work. And then last but not the least, I want to also say that a lot of customers get confused with microservices and containers. Microservices can also be in non-container world. So depending on what your use case is, actually your microservice can be within a container or outside, or without that container overhead. And of course, we expect the microservices to run not only on the cloud, but also on the edge and everything in between. So that actually, given that, let me talk about the platform which Azure uses for their microservices. So this is microservices, so Microsoft Azure Service Fabric. And this is the one which you want to build and deploy microservices in containers for Windows, Linux, or in non-containers. So we support both. So this particular platform is a proven microservices platform that makes it easy to build these microservices, which are scalable and also reliable. So we actually allow you to store state alongside your compute. So in terms of the platform, it actually is an all-up platform. So starting from us providing you an SDK with rich programming models like actors and reliable collections, which you can use for reliability reasons and also to store state. So certainly you don't want to use that for long-term storage, but certainly something which you want in memory. For example, if you're on a gaming platform, you actually want that real state to be in you. Then there's a good amount of dev and DevOps tooling which we provide out of the box. We do orchestration, as I was talking to you earlier, whether it's containers or non-containers. And also we give you a complete lifecycle management. So it is not that when you adopt this platform, it is not that you are adopting an infrastructure platform. We actually go application first. It's a developer first platform. So the whole lifecycle of deploying, monitoring, upgrading, everything is inclusive of what we support. And to help with that, we also have a rich health and monitoring pipelines as well, which integrate with external third-party and the first-party tools, which I'll just touch on. So the key about this one is, one of the key things which happen is we actually internally use Service Fabric a lot. So for example, this was one of the real enablers for SQL Azure to move from a box product to what it's now, a multi-billion-dollar business. So is Cosmos DB. So this is a platform that gets tested every day for its limits. I'll actually touch on this in a few slides as well. The last point here is it's available in all places where you want it to be, whether it's on-prem or it's on Azure. So Service Fabric itself, if you were following us, you would see this available in 3 form factors. One is on standalone. This is where you own the hardware, you own everything. You've taken the responsibility of owning end-to-end from hardware to the application deployment. And then towards the other extreme is the serverless offering called SF Mesh. This was the one which we announced last build. So we'll talk about it more. That's where we take away all the pain from you, and you're just focused only on the application development. So the middle one is where you actually have some amount of cluster development, and then the rest of it is something which we take care of. We give you automatic upgrades for not only OS, but also the fabric itself. So where do we use Service Fabric in Azure and Microsoft? So if you step back and think about it, it actually is from all the way from Office 365 and to one side to this Azure Container Registry in the developer side of the org. And then each of these are well known. And if you step back and think about it, the sheer volume which it runs. For example, Intune runs about 13 billion transactions per day. So it's stretching this platform to its seams almost on a daily basis. So we find bugs before anyone else finds it. And we are able to solve it and get to the next level at that point. SQL Server, for example, has 4.6 million Azure databases running on it. So it's not a small thing. For example, Cosmos DB, so then there is Event Hub, 3 trillion messages a day. So in terms of how latency-free you can make your deployments to be is a testament there. For example, Cosmos DB, which is a very popular offering at this point, uses 10 trillion requests per day. So that is the scale at which Service Fabric is used in Azure and also in powering the rest of Microsoft. So that doesn't mean that we have ignored our ecosystem. So we still have a lot of integration with ecosystem, not only from Azure, but also from external third-party offerings as well. Like, for example, if you look at monitoring, it's full of our partners which we partner with, and they have solutions on top. So I'll let you guys read it. I'll just skip over. And then specifically call out one thing, which is Event Hub, which I've seen in most of the deployments which you see now. Customers seem to have some kind of event-driven thing. So what they've done for us is they've given us a library which you can include with your services, which actually allows you to start listening to these events without having to do additional coding for it. So that is the URL for it, ak.ms sf Event Hub Processor. So what applications can you build with Service Fabric? So I've talked about the platform itself. So this is just an example of what we can build. So anything you can think about, you can build. So starting from enterprise mission-critical multi-tenant applications, like, for example, Society Generale runs their financial simulation software on it. So it's very mission-critical to it. Then if you think about from an IoT space, if you look at Honeywell, it actually runs all the thermostats and controls on that. You would see Alaska Airline, whose booking platform is something which is running on Service Fabric. So they use containers for it, of course. So they were just a lift and shift example, and they also do a lot of updates to it, and that's why I just put them in the DevOps pipeline kind of stories. And the Next Games is something which they recently launched, I think, in the last year. This was the first of their gaming platforms which they build, which they will reuse for multiple applications, multiple other games coming in. So there is your limits are your imagination. That's how I want to put it. So let's just talk about one such implementation, which was done by Eric Boyd for one of the popular companies. So I'll let him talk more about it.
All right, thanks, Jocko. So I want to talk about something that's super important for all of us. And that is our need for tasty, wonderful fried chicken. Not just any fried chicken. You'll see the big KFC bucket right here. Now, unfortunately, in my area, the KFC location is not terribly close to where I live. And in fact, to get to my KFC, I have to drive past a number of other restaurants. Confusing and distracting. But the good news is February of last year, KFC announced this great partnership with GrubHub, which means I can now stay at my home and order fried chicken and sandwiches and the amazing sides like mashed potatoes and gravy and biscuits, and that just arrives at my door. Now, this is a pretty big challenge for GrubHub, and so not for GrubHub, for KFC. And so they reached out to us. I'm Eric Boyd. I'm an Azure MVP. I'm a regional director. I've been working with Azure since the very beginning in 2008 and helping customers do implementations like this through our company ResponsiveX. So they reached out to us to help them kind of build this infrastructure. Now, it seems simple at first. I have an online ordering and delivery partner, GrubHub. I have KFC. All I really need to do is get orders, delivery information, and send some status back to GrubHub from the stores. And that seems simple, but there's already existing systems. We have existing systems on the delivery partner side. We have existing systems on the restaurant and the KFC side. And we're not changing these. So what we did was we decided to build out a microservices architecture to sit in the middle of this and coordinate all of this. So we have a service that receives orders from the delivery partner. We have a service that processes orders from the delivery partner. Delivery information, we process that as well. We dispatch that information to the store. We get statuses back from the store. We report those statuses back to the delivery partner. Now, this all seems simple as well, but as Chaco mentioned earlier, we need to have some loose coupling, some autonomous services. We're going to run this in Azure. It doesn't really matter where we run this, though, as well. So in Azure, I could run these front-end webhooks in an app service. I could run these back-end jobs in an Azure function. I somehow need to make these communicate together, so I'm going to put a service bus topic in between and have that loose coupling with eventing and messaging. I might also want to persist data to Cosmos DB, and I can do that as well. I can send those alerts and subscribe to those messages from my service bus topic and update the delivery partner. And I'll do the similar thing for the deliveries. I'll save some information to Cosmos, and I'll dispatch those orders all the way down to the store using IoT Hub. That's beautiful. I also want to store some secrets, so I bring in Key Vault. I also want to monitor and get some telemetry as to what's going on in my environment, so I use Azure Monitor, and I use App Insights. Now, this all looks well, but then there becomes a wrinkle. And that is, I need to manage this whole process in a very stateful way. I want this to happen at super low latency and do compute close to my data. Now, I could do that with a function, sort of, and I could just poll that data store, Cosmos DB, and I could have some latency built in there, but monitor it in a polling sort of fashion. Or I could just swap all of this out and bring in stateful services in Service Fabric. And this is where it gets interesting, because now I bring in an actor, and I have all of these things kind of loosely talking to this actor. And this actor is maintaining state and managing this whole process for me. Think of it like a state machine that's subscribing to lots of events all over the place. Now, I can still persist data to Cosmos. I can still event to something like a service bus so that other services can attach to that as well. So with that, I obviously could not bring a KFC store here today.
Why not?
I could not bring a string of delivery cars either.
It's fine, I'm vegetarian. I don't really care.
Mashed potatoes? No? Biscuits, maybe? All right.
Okay.
So instead, what we have is a simulation of what we built right here running in Service Fabric. In the upper left-hand corner, imagine this is you ordering from the delivery partner. So let's place an order. Now, I've provided the ability to choose the order number here, so I've just chosen an order number that is 1,000. Now, on the right-hand side, imagine this is the store. This is kind of a view of all of the orders that are coming in, and we're watching this in a stateful way as well inside of the actor model. So if I refresh this over here, I'm seeing there's my order. Now, there's a lot of things happening in this process. You'll see it's in a status right now that says waiting for confirmation. There's lots of statuses and orchestrations that happen in this process, and so when we confirm this back to the delivery partner, we'll get a message back that says, yep, we're confirmed, so let's simulate that as well. And when we do that, we will see we update our status over here as confirmed. We can start delivering this order and get the delivery information sent over here as well. And when we refresh, we get deliveries. When a driver enters inside a geofence to pick up that food that's tasty and bring it to our house, that happens, we get a geofence alert, and then we're now ready to send that back down to the store to actually make that order. Now, this is somewhat simplistic of a demo, so let me show you what's really happening behind the scenes so you believe what I'm actually saying here. So this is my order actor. I'm going to zoom in here because I see it's really, really small, and you're going to want to see this a little closer. So right here, let me zoom back out so I can get rid of some tooltips here. There we go. You'll see I have a method on this order actor that says process orders async. I have process delivery async, process store. All of those are receiving events in some way. Either they're receiving messages from a webhook, they're receiving messages from a bus or an eventing stream like an IoT hub or event hubs, and they're getting in here and setting some state. So it's very simple. You'll see that state manager on line 93 and 92 where I'm getting the state, and it's my order lifecycle. I then do some logic in there on line 94, and I process my order, and then I save that state back. It's that simple, and that's my actor in action. I then have some timers that fire, essentially using this reminder. Let me get rid of some tooltips again. And this reminder is triggering every now and then and saying, hey, am I in a state where everything is healthy, or should I remediate and take action to do something because it's not flowing through the process? As you can imagine, thousands of stores, lots of disconnected communication happening. I need to make sure that's flowing through the process. And so this is governing that and making that happen. So very simply, I have this stateful service, this actor, functioning and managing the life cycle of my order. Now, because I have this stateful service sitting here, it's very easy for me to also deploy my stateless services to talk to that stateful service. So instead of having to go through the latency of a queue or any messaging platform, I just have my webhooks sitting right in this service fabric cluster. And so you'll see here, I am calling into that actor from my webhooks that are sitting in this cluster and saying, go ahead and trigger that order actor and process the order, bring it in. And I do the same thing for the delivery information. So you'll see here that creating these actors, creating this amazing architecture that goes end to end with my stateful services and my stateless services was really pretty simple using Service Fabric, and I have the capability to really sideload and put my compute close to my data that's hot in memory and distributed across a bunch of nodes. And that's really the purpose of Service Fabric and these stateful services. I can co-locate that data and the compute onto the nodes in a distributed, reliable way. I have numerous programming models, or a few programming models. I showed you actors. We talked about stateless services too that I can run side by side. But I could also use some somewhat primitive sort of models as well, like collections and dictionaries in a reliable way. So there's a reliable collection and a reliable dictionary, and that gives me the ability to persist that state across numerous nodes in a reliable, fault-tolerant sort of way. So KFC delivering food to our house in February 2018, this was announced. In April of 2018, we were testing this in labs. In June, we were testing this in stores. So pretty rapid cycle here, thanks to Azure. Just this month, we've seen Food and Business News tell us that KFC is readying the rollout nationwide, so we can all order KFC and have it delivered. And this has significant impacts, not just on technology, but for your businesses. The digital transformation that's occurring in transformations like this, you'll see this headline from QSR, KFC is a global development machine, reporting its best growth in 3 years. So again, if you have any questions about Azure, microservices, Service Fabric, feel free to hit me up on Twitter or shoot me an email at eric.boyd@responsivex.com. With that, thanks, and I'll hand it back over.
Thank you.
Thank you, Eric. When you have something vegetarian online, let me know. Anyway, as a platform that's primarily designed and developed for developers as well as operators, I use the word develop a lot, actually, we've done a bunch of stuff this year. So I want to call out a few things Specifically, the three that you see on the slide. First up is the management of applications and services as Azure resources. So for those of you in the room that are familiar with Azure, you might have heard of ARM, or Azure Resource Manager. That effectively means that you have these resource types that are associated with Azure are considered primitives in the Azure world. And now Service Fabric's applications and services that you deploy to a cluster are actually associated with that. So what does that mean from a DevOps perspective? That means you can now manage these applications that you want deployed to your cluster much more holistically. The same way that you'd want to manage your infrastructure, you can manage an application. You can do a bunch of auditing, logging, testing, RBAC. RBAC is a specific one that's worth calling out because typically in the Service Fabric world and in cluster management in Azure, we have two roles. We've got the user and we've got the admin. But with enabling this for application deployment, the developer now can take on a role that's somewhere in between. You have the ability to add AD-based authentication, well, in this case, AAD-based authentication. So specifically, when I stand up a cluster, I can deploy applications to it as ARM resources, but Chaco cannot, because I don't want him touching my cluster. Even though neither of us would assume the role of user or admin, because the admin in this case would want to be able to do a lot more things. You'd want to manage the cluster itself, add, remove nodes, and all this infrastructure stuff. But within the scope of what DevOps actually means to us, we still want these hooks that are available for a person in that role to have that level of control, to have that level of access of information, and have that level of fidelity and control over the actual application. Specifically, another call out for this is there's something that was released in preview called the Azure Development Manager that helps you do a bunch of compliant, safe rollouts for complex Azure infrastructure environments, targeted specifically for DevOps people that want to deploy into these kinds of environments. And us enabling this means you can use that particular service as well. Second thing to call out is the HTTP-based client API. When Service Fabric first shipped, we had a bunch of client tooling available that was dependent on you actually having the Service Fabric SDK, because it came with custom bits that needed to be installed on the machines that would allow you to manage the cluster, make operations on the cluster. And here, now that you can have access to a cluster with different scopes, you will want to manage that cluster in different scopes. And what we've been able to do now is abstract away the dependency on those binaries that we were shipping just for Service Fabric to be based on HTTP instead. So from any machine, especially if you're not sitting at work at your exact desk, which has enabled you to get access to your cluster, now you're at home on your Mac, because that's what cool developers do nowadays, you'd be able to access your cluster and the operations that you actually want to do would still be available to you without having the full dependency set that we have. What's neat about this also is that this means that the whole DevOps pipeline that you want to set up through Azure DevOps no longer needs to be dependent on the Service Fabric SDK. You can check out more about this at the GitHub repo that's linked here. You guys will have access to the slides. What's worth calling out as well is that this is also available right now. Third piece I want to touch on is not yet available, but something we're working on, something we've gotten a lot of demand on. It'll be lit up in the near future, which is integration with managed identities. So managed identities, as some of you know, is a preferred way in which applications or code can actually reach out to get authenticated or get access tokens to different Azure services. And with MI, this becomes really easy, whereas today you'd have to do a bunch of API calls to Key Vault, and your code would look substantively more complicated the way it does today than once we've been able to get a nice integration with managed identities. So let's talk a little bit about what that actually means from a code perspective. So this is a relatively generic token callback function. It's pretty common in most Azure services. If you were to write an Azure function that needed to use a managed identity, your code would pretty much just look like this. And what's worth calling out here is you guys can see the two highlights. There's the MI endpoint and the MI secret. You're actually getting these two values as an environment variable on your application. So you just import that into your code, and then you can use that down here where you see the request message. It's using the token that's generated based on the actual environment variables that are coming in. So at deployment time, you can supply the actual endpoint and the secret that you need to use to access whatever other Azure services that you're actually using. Which becomes a lot niftier from a coding perspective. It allows you to be a lot more agile with secrets rolling and updating in the future, and should simplify your code significantly in this particular space. There's a bunch of other stuff as well, but we're going to jump further into Service Fabric success as an enterprise-grade platform and why it's important for you guys as you look to build mission-critical services on top of Service Fabric. So I'm going to hand it back to Chaco real quick.
So one of those things which we did in the beginning of the year is just look back into all the volumes of CSS tickets and the incidents which we're getting. And we decided that we're going to start now, this year will be full of trying to prioritize those features which make or move the customer pain away in terms of managing cluster itself. So we invested time in the reliability space, the security space, and also the auditing space. So specifically, I want to call out something which we did to improve safety checks so that customers don't accidentally go delete VMs which really have their master nodes running on them. So those are things which we've seen as happening very often, and so those things which we change, we have actually deep integration with VMSs now, which will prevent you from doing it. Even if you tried, it'll actually fail that no, you cannot, because you actually have a reliable sys service running on it. So that's kind of interesting things we have done. The other one which we did was, today, the number of UDs are limited to 5. So that means that if you have a 1,000 node cluster, at any given point, you have to be ready to lose 200 of them for an upgrade. So that actually is too much for any planned maintenance. And so we're going to give you the ability to specify how many or what percentage of nodes do you want to take down at any given point. And so on the same reliability thread, we also now support the cross AZ clusters. So we'll have a demo for it soon so that Deep can show it off. And just to go and complete the rest of its security. So this is one thing which the engineering team pay a lot of price, because we didn't do this job before, where we now allow customers to auto-rotate the certificates rather than go in and change manually, and sometimes you forget, and then you're just locked out. And then you have to call us, and then we we go behind the scenes and monkey with it. And it's just a downtime for you guys. So that's going to be gone. And we'll also not allow you to deploy invalid certificates. It's amazing if you start going to the common names. Sometimes people just forget that this is not the right certificate to deploy to this cluster, and then hoses the cluster out. So those are things which we're going to prevent. So more and more, we want to relieve you of the pain point which you have with managing your clusters. That doesn't mean that we don't want you to go to the serverless side of it, but for the customers who cannot because of compliance reasons and stuff, we want to make it an easy thing. And so similarly for auditing, so anything which you do through RP can be audited. This was a gap which we had. We've filled it at this point. So anything you do can be audited from the top end. And we also talked about application services as ARM resources that will also add to your auditing capabilities and diagnostics. We also enable syslog. So that actually now, if you are one of the fans of Prometheus, you certainly can start using it as where you consume these things. For customers who are looking for throwaway VMs to be a part of their cluster, we also have support coming for the low priority VMs. Truly, the keyword being volatile workloads. If you care about your workload, do not put them on volatile or low priority VMs. So these two are available. These three are available. So let me just go and let him show us as a HA with cross AZ clusters.
Cool. So you guys are here to learn about deploying mission-critical applications. So what does that actually mean? You're designing for the case in which even when things go wrong, your users are not actually impacted, your workloads are not actually impacted. So we have this thing called AZs in Azure, which stand for availability zones. Most Azure regions have 3 availability zones within them. And what we've got here is basically a cluster that spans 3 availability zones in one particular region. What's worth noting about availability zones is that they do represent individual data centers where they have their own power, their own network, their own cooling. And the disaster you're really mitigating here is in case an entire data center were to go out from Azure, what would you be actually able to do? What would be the situation that you're stuck in? So as you can see here, this is a cluster rough topology. It's a diagram that shows you that there's 3 node types. Each one is mapped to a VM scale set. They're all within the same cluster, of course. They're all wrapped within one VNet. There's only one public IP in front of the entire cluster and one load balancer. So that means from your user standpoint, from the people that are accessing your applications that are hosted on top of such a cluster, it doesn't feel any different to any other cluster. It's just that the actual infrastructure is distributed across 3 different data centers. So let me show you what that actually looks like. So this is Service Fabric Explorer. For those of you that haven't used Service Fabric before, it's like our dashboard that gives you a great point-in-time source of truth of what your cluster actually looks like. So you can see there's 15 nodes here. There are 3 in each AZ. I'm going to quickly show you. So this is our cluster map. So this is literally our cluster topology, but what it actually looks like, you can see that there's one VM across various different fault domains. So if you guys can see here, the region we have is ECS2. Then we've got AZ1 here. Then there's a set of 5 VMs in AZ2 and a set in AZ3. What we've deployed on here is our Visual Objects application. So for those of you that have played with Service Fabric before and seen our samples, you might know what this actually is. But for those that haven't, Visual Objects is a pretty simple application. There's a web UI that renders a bunch of pyramids, and the pyramids move based on what a worker tells the pyramid to do. So effectively, you've got an active service that's coming up that's associated with these little pyramids and says, every next second or every next refresh of the UI, go to the right and go up at a certain speed. So what you'll see when I pull up the UI is you'll see a bunch of pyramids that are moving around. What's worth also realizing is that the color of the pyramids is denoted by the AZ that they're deployed in. So you'll see 3 distinct colors. And what I'm going to do is, because I can't just turn off an Azure data center for fun or for the sake of this demo, or no matter how big this room is, I can't actually just do that. I don't know, maybe I can, but I don't want to know if I can do that. So instead, what I'm going to do is I'm going to just simulate the nodes going down in an AZ, and you'll see what happens. So I'm going to switch back to my demo application, and I'm going to show you guys what's deployed here. OK, everybody can see the pyramids? All right, cool. So I don't know how well this is rendering, but there's 3 different colors. And what I'm going to go ahead and do is I'm going to run a little script that my teammate Peter put up for me that basically connects to this cluster. And of course, Peter, you are not a trusted source of PowerShell. You should get to PowerShell and tell them that you're trustable. What I'm going to go ahead and do is I'm actually going to disable the first AZ. So what you should see happen here when I hit this is the pyramids will actually stop, because the services that are running that AZ will stop. But then they will recover, because Service Fabric will effectively move that workload to a machine that's actually alive. OK, so anytime now, what's happening?
Yep, it's happened.
There we go. All right. So the orange ones all went down. The slowness was actually the internet, not the AZ. But now you can see that they're back up. It was. And effectively, what's happened is, as you can see, some of these nodes are now in a disabling state. Obviously, I'm not going to wait for them to actually go down. But basically, what you saw there is what would have happened in the case of an entire data center actually going down, where your application would be able to recover just because of the fact that it is running in Service Fabric, and we're able to place your workloads in the right sort of location to do that. Anyway, let's jump back to the deck. One of the big reasons you guys are here is specifically to talk about microservices. And when we talk about microservices, we often talk about containers. So let's shift to discussing containers.
All right, so this is good. So the key about this one is we continue with our theme that we want to reduce customer pain. This is something which we are very much fascinated about, and we are committed to it. So same thing which we did, we actually started to add more container diagnostics to these container workloads. Because it's very difficult. Customers who have tried containers, this is one of those big things is you can't do an F5 on a running container. It's just very difficult. You just cannot. So you have now you think about other ways to do it. So that either the platform provides it or do something else. So we are now trying to give you all the container views, which is more verbose, so that now you can look at your logs and figure out what's going on. The other thing which we are also doing is making the Azure file volume, which you could actually attach to your containers for making them a little bit more stateful. So that's something which we are getting it to GA at this point. Then the 2 other things which I'm pretty excited about is we are now also going to support Server 2019. This is something specifically we started to integrate for our mesh offering. And so that's something which we're bringing to the cluster offering as well, because the runtime is the same. That is, when we say it's the same runtime, it actually is the same runtime. We just package them differently. And so this one will allow you to do process-based isolation, isolated containers, and also kernel mode isolated Hyper-V containers as well. So this will allow you to run both Windows and Linux containers on your Windows clusters. So that actually is what the value prop for this one is. We started to do that internally as well. So there is a talk which Taylor Brown did about what this technology is all about. So I've referred it there at this point. The last thing is we actually also want to make a volume disk supported by Service Fabric and behind the scenes reliable collections also be available as a volume disk. It's not meant for very high storage volumes. It is mainly, it gives you the simplicity of using IO-based protocol rather than knowing our own SDK. That actually was the key reason for enabling it. We are actually getting into preview at this point. So So one of the big things about Windows containers, there are mission-critical applications which are running on using Windows containers. We're privileged to have Kai from Zeiss, who's going to talk about how he used it to create a mission-critical app running Windows containers.
Okay. So thank you, Chaco and Deep, for having me here. Hello all. My name is Kai Walter. I work with Zeiss. Zeiss is a technology company. We're leading and we excel in optoelectronics and optic devices and components. The devices we have is the foundation of our success. For instance, close to 40 Nobel Prizes were won on Zeiss devices like microscopes, Zeiss camera lenses. Inside, Hasselblad cameras went to the moon. 1977, basically modified camera lens was put into the first semiconductor wafer stepper, and right now it's safe to assume that most of the microchips you have in your smartphones or whatever devices, 80% of them are made with Zeiss optics. This means that Zeiss devices are rather complex. If you look at a neurosurgical microscope, which is basically used to fiddle around in your brain.
Thanks, guys. It's really reassuring.
These are rather complex devices, meaning teams pulling off this kind of devices, they have to tackle with hardware challenges, software challenges, and with hardware not only electronics, but only the mechanical parts. Yeah? So a surgical microscope has to move very stable. And when we started digitalization, meaning bringing our processes to the customer, in 2016, we realized, okay, we need to make it simple for these teams to integrate with whatever capabilities we have in the back end. Yeah? For instance, order to cash process, to order consumables or accessories, or to request for technical service, or to access any knowledge. We wanted to make it very simple for those teams, not to put an additional headache of integration on top of these teams. And for that, now where do I need to point it? Here. For that we decided, okay, we go for APIs. Every business capability we have, we want to expose to these devices or even other customer touch points which are intended to make interaction with Zeiss simple. We expose over an API, and those teams, they can just use it. But an API in itself is not sufficient, because most of the back-end systems, they are not able to expose something like an API. So there's still a way to go. And for this way to go, we pulled off a whole stack of Azure technology, and we did that in the cloud. Why did we do that in the cloud? We needed the speed. We need to bring it up fast. We needed to be agile. That means bring up, try, maybe tear down stuff without any regrets. And we were aware that most of our consumers live in the cloud or in the internet anyway. Yeah? So we need to isolate them from the corporate network or from the corporate systems anyway, and we want to have only one single entry into our world. And in this stack, we utilize a lot of the Azure components. So we have application gateway with the web application firewall to protect our endpoints. We obviously have API management to help with the API lifecycle management and with the API gateway. We have Service Fabric for our stateful processes. We have Azure Functions for all the stateless stuff. We have Service Bus queues to put message in, asynchronous messages in. We have Cosmos DB to cache business documents, which might be needed later. And then we have also blob storage to unload payloads from Service Bus into blob storage. And this infrastructure here is connected over ExpressRoute to our corporate network. Now, we wanted to go in the cloud. We wanted to apply platform as a service as much as possible. So remembering it was spring 2017, most of the components could not live inside a protected virtual network. So for instance, Azure Function, you could only use in an app service or consumption plan, Cosmos DB also. But anyway, we wanted to protect these resources as good as possible. So we started right away. We started with not so critical use cases. We left those services on public endpoints. And as soon as services offered these service endpoints to connect them to the VNet, we pulled them down and locked them down in the VNet. Okay, back then, Service Fabric and also API management were one of the few resources which truly could live in the VNet. And for that reason, we focused on Service Fabric, everything which had to talk to backend systems. We focused on Service Fabric. Okay. And we applied stateful scenarios. We heard about that from Eric. In our scenario, it's pretty much the same. Order comes in, order is collected by an actor, and then the actor controls the calling of the producer. This could be several times. Whatever the producer...
It's like animation back in the day.
Yeah, yeah. This is where I come from, yeah. This is how we did animation back then, yeah. And
then you're going to take photos of my brain. Yeah, right.
Also, when feedback is coming back from the producer to the actor, it's the same. Could be one or more times. The actor basically collects all the feedback coming from the producer systems, and when the process, whatever this is, this could be a software update a customer is doing with us, reaches a certain state, it is pushed to the consumer. Yeah. For that, you can use Service Fabric. It's pretty easy. From a developer point of view, this actor model is simple to use. Yeah? It runs very good. But most of our scenarios were stateless. And this is what I always push when we do integration scenarios. I want to have them stateless. Yeah? And how do we do stateless? Information is coming in from the consumer over API. It's put in a queue to detach it, and some poor function has to deal with the producer, meaning also slowing down traffic to the producer. Not all the producers are able to handle a lot of traffic. In the same way back, when the producer has some feedback to send back to the consumer, again, put in an API, in a queue, and then a function either pushes it to a consumer. If the consumer also does not like to be pushed, put it in a Cosmos DB and let the consumer decide when to fetch this information from Cosmos DB over an API. However, our target was to bring that into the VNet all the time. We wanted to have it in a VNet, and for that, then in summer to autumn 2017, we managed to bring Azure Functions inside a Service Fabric in Windows containers up and running, which were truly protected, not visible to the outside, only in our environment. How did we do that? So this is now the Functions v2 model. So with Functions v2, you already have a pre-canned image you can use from Microsoft and maybe adapt it a bit. With Functions version 1, I had to do it totally on my own. But anyway, we are now in v2 world. So we have one master image where we put the runtime on top. We also can put corporate certificates in this container, so we can really size-amize this container with the functions inside to our needs. And then we have some entry script, which I touch back later on, which also does a lot of magic stuff. So this is one master image, and when we want to put function app inside Service Fabric, we just go from that master image, put the app inside it, the function app inside it, do a simple Docker Compose deploy into Service Fabric, and that's it. So Azure Function running inside Service Fabric can be called either over HTTP or picks up from queues, picks up from event hubs, everything. So Azure Function does not realize the difference here. We even managed to bring more convenience to that. So in that startup script, we also connected to managed identity. We resolve this nice Microsoft Key Vault notation you also have with Azure Functions in App Service. We transform them into environment variables you have then inside the container. Means the model we currently have has closely the comfort of running functions into in App Service. Yeah? How are functions called or containers called? This is solely done with API management. API management for us acts as a kind of orchestrator. Our containers are only called from an API, either from external APIs, which are available to our consumers, or if we have to call within our platform, it's internal APIs. It's always an API. This means we do not need a fancy wiring up of containers. We always come in top-down, either an API call or, as I mentioned, a service bus queue or event hub. So basically, API management gets the call. API management talks to the backplane of Service Fabric, telling Service Fabric, I have here my function app. Where is it? And then the Service Fabric management environment resolves it into a certain node and port. And with that, we solved the problem of orchestration. So what's more to do? In our environment, we already have a model which we call bring your own API. So we allow other teams we have at SAIS to host their APIs in our environment because it's there, it's stable, it's proven, we have deployment processes. And where we now want to go is that within our environment, with all access to the SAIS resources, other teams can also bring their container and workloads to us. So with that, for us, acting like a platform, giving a platform to our community, our internal community. Technology-wise, Service Fabric is still infrastructure. You have to manage it. So the next step will be here to look for the serverless options we have, either Service Fabric Mesh or Azure Functions. And with that, serverless, I hand back to...
Thank you, Guy. Appreciate it. So let's talk serverless, right? So we've spent some time talking about the first two offerings in the sense of what Service Fabric traditionally means to people, how you can use it, how you can deploy to it. But really, the part that we want to spend some time on as well is Service Fabric Mesh. So what is Mesh, right? So as Kai mentioned, managing infrastructure is not trivial. It takes time, it takes effort. When we first went out with Service Fabric, we got a lot of feedback related to how difficult it was, actually. And over the last year, we've continued to get that, like questions like how many VM skill sets should my node types do I need to have? How do I do this? How to do that? There's a bunch of stuff. We don't want you thinking about that, okay? That isn't where you should be spending your time, and we want to make sure that that isn't the case moving forward. So we want to take this and get rid of the fact that there's an infrastructure problem, there's the fact that there's applications that are deployed onto the infrastructure, simplify the whole thing. And so we built this thing called Service Fabric Mesh, which is a fully managed Service Fabric, or a serverless Service Fabric, effectively, where all you need to focus on is your actual application and the deployment of that application, and let us handle the rest. So we went and we built this thing. The intent behind it was we've abstracted away the entire Service Fabric aspects of it. There was no VMs, no OS in the picture. All of that was taken care of you. It was like an easy deployment to Azure. And I shouldn't be saying it was. It still is. And the intent was you get an SLA effectively from us that says your applications will run with a certain amount of uptime, and we'll take care of the rest. So we went into preview, as some of you may know, last July. We went out with this thing called the Service Fabric resource model that had primitives defined for applications, networks, secrets, volumes, gateways, and autoscale. And we've been working heavily on evolving Service Fabric Mesh since then. Some things to look forward to for those of you that are following the preview along. Specifically, we'll be doing a refresh in the next couple of weeks that will bring in support for Windows Server 29 and 1809 containers. There'll be the integration for managed identities that we showed earlier on that you'll be able to use in Mesh as well. And then there'll be some improvements to the monitoring experience. And my favorite part, I'm going to get to start charging you guys at 50%. Beyond that, there's still other things we know we need to light up. Specifically, the thing worth calling out here is the bring your own VNet scenario, which I know a lot of people are looking forward to. But what we're here to talk about a little bit as well is where is Service Direct Mesh headed? How does it evolve? So I'd like to hand it to Chaco to tell you a little story.
All right, so I have like 10 minutes, so I'm going to make this very quick. So if you step back and think about it, the whole journey started off by saying that we want to take the pain away from customer to talk about the infrastructure itself. So if you step back and look at it, there are two pieces to it. One is the SF resource model. This is the only thing a customer deals with. It talks about application services, secrets, containers, and so forth. And then there is the invisible piece, which is the infrastructure piece itself. So this is the piece which we realized from a couple of other things which we talked about, and also like from the feedback which we got, that we need to do something which is more than Service Fabric. We're actually, because SF resource model itself has nothing to do with Service Fabric. If you step back and look at it, it just says application services and containers. It does not talk about any programming models or anything. So late last year, I think at that point, we decided to onboard the Linux functions service onto Mesh. So this actually now was interesting in terms of strategy, that we will have the same investments which will be made, which will be available to the Linux functions team as well. So the key thing is we didn't realize that, well, Linux function also brings in some strange and very unique requirements of a platform, because containers take about 30 seconds to 5 minutes to start when you request to coming up. Even in Mesh, that is actually the thing. Even if we cache some of the popular images, that seems to be the thing. So we ended up having server pools. We also had some special asks from them in terms of, can I inject some of my agents onto the box and so forth. So the more we thought about it, we said, okay, that the right thing to do it is to now start to think about giving them some building blocks. You should be thinking in terms of blocks where the kids play with, so they can actually make the castle you want. So that is what we started doing, and then at that point, this is now the end of the year, like sometime around December timeframe, when some of you guys signed up for a Go Live license. This is where we got good feedback saying, okay, now it's great that it's a very stable product. I'm able to put something in production. But why is it so limited, and why are we not going and making it available to a wider audience? Why not all the developers who really want to get out of this infrastructure management? So that actually is what really happened. And so we started to evolve the app model. So the direction of where this app model is going is that it actually would be an OSS-friendly app model. Specifically, we are targeting the K8 audience, so that now this app model, all this based off our SF resource model, it will now have extensibility built into it. And then, so there is more details coming. I'm not authorized to tell you as to when it will be announced or what's going to happen. In terms of the timeline and what the shape of it is. You just have to wait for maybe a month or so for more details coming out. But all the same, when I step back and when we internally were looking at it and thought, okay, now that if we start to adopt, we've now talked about this evolved app model service, which is running on it today, and also the Linux function service is running, the Mesh apps are running on it. So we wanted to now say, okay, what would we call this control plane? We should actually rename it to something which is a little bit more reflective of the fact that it is not just Service Fabric. So that's how we started to calling it Atlas, the serverless container platform, which would be the bedrock for Azure for any of the container services going forward. So anything, be it, so for example, container instances, so that my team owns that service as well. So we are in the process of replatting it onto this one. Because there's really no reason from a customer perspective to care about what orchestrator is running or any of that. That is not the SLA you guys are looking for. You're looking for how quickly can I get my container from the GitHub repo or from the ACR to running. So that's what you will start to see. And so what's going to happen at that point is, so now once ACI comes on, what you will see very quickly is, for folks who were actually in the keynote on Monday, we talked about virtual nodes. We talked about serverless Kubernetes. So we started now light up that particular offering as well. So when you go to AKS, or say, for example, like there was a partner I can't name who was trying to connect their Kubernetes cluster through Express Route and then burst into cloud. So those are things which start to enable. And then so this is the direction we're going to take this particular mesh preview to. So anything future and multi-tenant. So as I talked about before, one of those things which we have explicitly said is we are going to, this particular platform, which is started off with mesh, is going to evolve to a point where we will provide building blocks for other services to be built on top. So all the goodness of Service Fabric, which we talked about, including statefulness. I don't know whether you guys watched the keynote, or not a keynote, there was Channel 9 talk with Scott Guthrie. So he spilled the beans by saying that, yes, we are actually also thinking of replanning a lot of functions and also bringing statefulness to the OSS community. So that is where we're going to head with this. At the end of the day, customers interact with the app model, with the programming models. So that is what we want to get to. That actually is the future of Service Fabric Mesh. So you would see that the evolved mesh model, or evolved app model service would be announced pretty shortly. And at that point, anyone who was a part of the mesh preview would actually be grandfathered in, or the request will be sent to you guys so that you can actually onboard to that. It is an extension of the resource model itself, so it will look very familiar. So it is not that there will be a huge learning curve there. People who have gone live with us, we've already talking to them, and they know this is the story. We will give them the same support, which we've given them thus far for the production support in terms of their production workloads. They will continue to do that till they're able to move off to the new service. That actually is the real story. So I wanted to make sure that if you guys heard it from the product owner for this. So that's why I wanted to take the time and talk to you about it. I know this was something which is the big elephant in the room, so I wanted to address it right on. And if there are questions, absolutely, reach out to me, and we will certainly talk about it. I have 3 minutes, so I'll let Deep talk. Think about, think about the imagination or kindle your imagination of what can you do with such a platform behind the scenes.
Okay, so this is one of my favorite demos if it works, because it's just showing off. Literally, there's nothing else. And the intent with this one is that we took a fork of the code of the visual objects thing that you just saw. And actually, I need to switch this over to my demo machine in a second. We have a Fireworks application that's deployed. The same concept, worker services are reporting to a main web application for each web instance that's running. There's actually a little firework that's exploding in the sky. I'm trying to get this thing to switch. I think I have the right machine. All right. So you guys can see it here. I issued a command as I switch the screen to basically scale up this application from 3 services that have 1 worker each to have somewhere over 1,000 workers each. I did nothing else. I have no idea what cluster this thing is running on. I just decided to launch, and I just picked 1,000. I prayed for about 20 minutes to the demo gods before this. I'm hoping that got me to the 1,000. I don't know. But you can start to see that they're starting to scale up. Each iteration is sort of coming with more and more fireworks. Each one of these fireworks actually represents a live container that's been deployed in a fully serverless way. I have no idea, again, like I said, what the cluster is. I just went into Azure CLI. As some of you are familiar with Mesh already, the experience feels like this, but it's not at the scale that this thing is at. So eventually, this thing will start to scale up. It will, in about 2 minutes or so, it starts to hit 1,000. I don't know if we've got more than 2 minutes left. I'd say we switch back to the slides, and then I'll show you guys what it's looking like right at the end of the talk.
So I think it'll go. Just wait a second. Give it 30 seconds. So,
all right, we'll give it.
The key about this one is just let it be a wow movement, right? It's okay. It's worthwhile. Is what I would say. So this always is impressive to me that you can actually request a simple CLI command, takes you to over 1,000. So this is 3,000 containers running on demand.
The browser's going to crash.
Yes.
That's what's going to happen.
Is that what's going to happen?
Anytime now. And for all those of you taking photos of this thing, that image at the back is fully copyrighted by me, so you better be paying me for this.
All right,
it crashed. All right, the browser crashed.
So refresh it.
I'll refresh it. It's just going to look like a swirly mass.
Okay. So while this is coming up, maybe I can talk about the next slide. We actually have worked very hard to come up with some of the reference architectures to specifically, that's fine. You should still
Sure.
keep that.
Sounds good.
Yeah, because links are interesting. So this is the reference architecture and solutions for Service Fabric. This is something which the customers have asked for us. So we just said, okay, we'll just give you for modernization of your applications, the cloud-native applications, IoT applications, and so forth. So anyway, it's not helping.
It's Chrome. I should have used Edge, obviously. That was a mistake that I made.
There
we go.
Oh, there it is.
Okay.
So that's what you would see happening. And so anyway, so let's just switch
It's going
to.
to crash again in a second, so I'm just going to...
So it's too much of reporting going on. So I have 45 seconds, so I'll just go quickly. So here are the reference architectures. Please go give us feedback. Unless you guys give us feedback, there is no real way to find out if it's real or not. That's why I actually had the fortune of getting 2 real customers on board and talking about how their experiences was. So that's important. Here are all the resources. So if you just go to the ak.msSF, you should get a ton of this stuff there. So about 20 seconds left. So when do you use Service Fabric? You've heard a lot about the containers and so forth. So I would say if you're using Service Fabric today, please continue to use it. We'll continue to evolve it. We'll continue to have more and more customers use it. The fact that if you are a .NET ISV, absolutely sell more Service Fabric because that is something which you have signed up for. You actually have taken the time to build expertise for. If you need programming models, if you need Windows containers, stateful services, or guest EXCs, for example, if you want a Java EE running in a reliable way, this is the only way to do it at this point. So I would say the biggest takeaways, I'm actually running out of time, so I'll just say biggest takeaways are Service Fabric is the core foundational component for Azure. So we continue to see the growth, so we will continue to invest in it. We can orchestrate both containers and non-container workloads or mix them together. It is an application platform first. It gives you a lot of programming model capabilities, which we just highlighted with 2 great examples here. We would continue to add more and more features to make it more reliable. And of course, the new serverless platform for Azure is built on the technology which you have in your hands. Thank you for your time.